Good evening to our lecturer for ECS 1303, which is Computer Organization and Assembly Language subject, Miss Lo Wang Ning. Today, me and my groupmates will be presenting about our final group project for this subject. Our group consists me, myself, Abel, Musa, Corinthians, and Maizatul. Without further ado, let's begin in our project. To introduce our project, we chose rock, paper, and scissors, which is a simple and widely known game between two players. Based on the rules, which rock beats scissors, scissors beats paper, and paper beats rock. Because of its simplicity, it is often used in programming to demonstrate logic, user interaction, and decision making. This project also focuses on developing rock, paper, and scissors using assembly language, which is a low-level programming language that provides a direct interaction between hardware and memory system. The purpose of this project is also to enhance students' understanding of fundamental programming concepts, which is conditional branching, loops, and handling. At the end of our projects, we we built this project is to develop a rock, paper, and scissors game using assembly language. It is also to help ourselves to understand and apply low-level programming concepts such as registers, memory usage, and instruction sets. And lastly, it is to implement basic programming logic, including conditional statements, loops, and user input-output handling.
Hello, today my part is scope. The first scope is the game is designed for single players against computer. That means that the user will be playing against the computer. And then the second is user input is the user input is restricted to three choice, which is rock, papers, and scissors. And the program will generate a random or predefined computer choice. And then the system will determine and display the game result, which is win, lose, or a draw. And then how it works, you may ask. The program will ask the user to choose rock, paper, or scissors, which is R, P, or S. It will then generate a random choice for the computers and compares both choice based on the game rules. And finally, it will display the computer choice and show whether the user will win, lose, or ties with the computers. And then this is the project overview. This was this project was developed in Microsoft Visual Studio using x86 assembly, which utilizing window API function to manage input and output. And then the two main session is .data, which define message, user input, buffers, and variables in the coding. And then .codes mean primary execution logic, which processing, which include input processing and computer decision making. And then there is also the program flow for the projects, which will the first is it will display an introduction message, and then the user will enter his choice whether he will choose R, P, or S, which is rock, papers, and scissors. And then the computer will choose his own choice, which is rock, paper, and which is also rock, papers, and scissors. And then the system will compare both inputs, and the result will be displayed to the users.
Hello, my name is Corinthians and I'm going to continue my part. So, input handling. Our game use read console A, which is the assembly terms for Windows API. Our user can enter R, P, and S, which each of them are representing rock, paper, and scissors. So what happens if one of our users inputs the invalid alphabet? For example, if they enter G, well, the systems automatically will default it back to R. So regardless of any alphabet that you try to put, it will always be R. Any invalid inputs. So the inputs are stored in a buffer and moved to register for processing. Next is computer choice logic. We use getTickAccount to get the system time in milliseconds. This acts as a seed for randomness, meaning it's not going to stay the same. It's always going to be changing. So how do we do this? We use the mathematics. We divide by 3 for every single possibilities, meaning that the remainder is 0, 1, 2. Each of the numbers are already been assigned, so 0 being rock, 1 being paper, 2 being scissors. It is a simple but effective pseudo random method in assembly. So, decision making. Our game use CMP, which is compare in assembly terms, and conditional jumps. Our game has only 3 outcomes, whether it being the user winning, or the computer win, or tie, meaning that both sides win. Lastly, the structure of the code is very clean, which shows the control is very, very smooth and flow easily.
Moving on the technical implementation of our output system, to handle how the game display text, we utilize the write console a Windows API. This allow our assembly program, this program, to communicate directly with the console. All our strings, such as the game title and result, are stored in the data sections. So, which means if you look at the snippet codes on the right, we created a custom procedure called print str. So a key feature here is that automatically calculate the string length. And also it use a count loop to scan the memory until it finds a null terminator. So this make our code make our code more much efficient. And as we don't have to manually count characters for the every message we display, so whether it's the introduction or the final win-lose result. All right, for the next slide. So as you can see over here, the game actually looks and plays. So as shown in the screenshot, the game starts by prompting the user to choose R, P, or S. So we designed the input to be user-friendly. However, we also complete an error handling if a user types any other character. So the system will automatically default their choice to rock to prevent the program crashing. Not crash at all lah. And then for the computer turn, we use a pseudo-random method by taking the system get tick count and applying a modulatory operation. The computer randomly select move and the result whether it's a tie, a win, or lose. So it will determine and display instantly to the user at the program output. Okay, next, to wrap out, let's look at the key improvement, which is our game improvement and the feature we implemented in this version. So we have focused on making the assembly program robust and structured, and the program supports both uppercase and lowercase inputs and make it more flexible and for the player, and We included the default values for invalid inputs to ensure smooth execution, yes. And then we implemented the structure decision making logic to handle the game rules accurately. So, and finally, by using reusable function like our output display pro. Okay, next, I will give to my friends, pass to my friends. Thank you.
So now we're going to look at the IPO part, which is the foundation for every system development. Now we're going to look at the input. User are sorry, user are required to put R, P, and S as an input, and then the computer input, which will generate number from 0, 1, and 2. So now we're going to look at the process. For this part, I'm going to separate it for 3 parts. First, we're going to look, the first part is the interface, the second one for user instruction, and lastly for computer instruction. So for the interface, it will display the rock, paper, scissors game. And then we're going to look at the user instruction. It will display choose R for rock, P for paper, or S for scissor. And then the computer will read the user input, and then it will store it in the user choice. And then it will determine user choice. It's either R, rock, P for paper, and S for scissor. And now we're going to look for the computer part, computer instruction. My bad, sorry. It will generate a random number from 0 to 2. It will determine computer choice. If 0, it will become rock. If 1, it will be paper. 2, it will be scissor. And then it will display computer choice. If the random math happen to be 0, and then the choice for computer will be rock. Now we're going to look for output. It will display game title. As you guys can see, during the process we can see display the game title, which is rock, paper, scissors game. So that will be the title. And then it will display instruction for user. It will display computer choice. For example, computer choose paper. So we can see if the computer choose paper, the random math will be, the number for random math will be 2. It will be 1, sorry, my bad. And then we will look for the next one. Okay, so for conclusion, in the end, we managed to create a fully operational prototype game, deliver in interactive game, that will be improved in the near future. That's all from us. Thank you.